First question, as the mass number increases, the binding energy per nucleon. Okay, so we know the graph of binding energy per nucleon. Binding energy per nucleon. Okay, and here is the atomic mass number. Okay, atomic number graph. So the graph moves like this. Okay. मैम अगर मुझे बीच में रोकना है, आप क्या करूं? थोड़ा सा गड़बड़ हो गया बनाने में. Okay, so now binding energy per nucleon versus binding energy per nucleon versus atomic number graph. Okay, so this graph looks like this. Okay, so we can see that as the atomic number mass number increases, then the value of binding energy first increases, then decreases, and gets to the maximum value, and then again it starts decreasing. Okay, so it is not constant, it is not continuously increasing, not continuously decreasing. So the fourth option, D will be correct here. Okay, second, the ratio of wavelength of deuteron and proton accelerated through the same potential. So V is same. Okay, now we have to calculate the ratio. So for deuteron, let's say the wavelength is given by h by p now, and p can be written as momentum, can be written as 2mqv. Okay, so here we can see that lambda is inversely proportional to root under mq basically. Other quantities are constant here. So if I write it lambda d by lambda p, it will be 1 by root under md qd into root under mp qp. Okay, so deuteron is what? It is basically a proton having one neutron. So the mass of the deuteron is double of the proton. So md is 2 times of mp, but the charge is same. So qp is equal to qd. Okay, so now if I put the value, I will get lambda p. So it will be root under mp qp upon 2mp qp. So it will be 1 by root 2. Okay, the correct option is A. Third, when the light of wavelength less than 6,000, so lambda less than 6,000 angstrom, okay, is incident on the metal, electrons are emitted, the approximate work function. Okay, so maximum wavelength can be 6,000 angstrom. So if we know energy is inversely proportional to wavelength. So if wavelength is maximum, energy will be minimum. And for minimum energy, the kinetic energy of ejected electron, the minimum kinetic energy of ejected electron can be approximately zero. Okay, can be zero basically. So we know the equation E is equal to K plus phi naught. Okay, here is the incident energy of incident photon, K is kinetic energy, and phi naught is power function. So for minimum kinetic energy, E is equal to phi naught. Now, what is E? E is the incident energy of incident photon, that is hc by lambda, and the value of hc can be taken as 1240 nanometer electron volt, and lambda in terms of nanometer will be 600 nanometer. So nanometer get cancelled, and this comes out to when we calculate this one. So we get phi naught equal to 2.06 electron volt. That is approximately 2 electron volt. Okay, so the B option is correct here. Fourth, if the full wave rectifier circuit is operating from 50 hertz means the frequency of the output voltage. So we know that in full wave rectifier, the input wave is like this, input, okay, and in full wave rectifier, the output wave is like this. So here we can see that frequency is getting double. If I am applying 50 hertz frequency here, so I will get 100 hertz frequency here. Okay, so the D option is again correct. Fifth, two NOT gates are connected at the two inputs of NAND gate. So say this is NAND gate and NOT gates are at inputs. Okay, let's say here the signal is A and here it is B and the output is Y. So I have to tell which gate it is. So here I will get A bar, B bar, and at the output it will be A bar dot B bar to whole bar. Okay, so the output will be A bar dot B bar whole bar. Now I can write it like A double bar plus B double bar, and it will be A plus B. And which gate is it? It is OR gate. Okay. Now the sixth one, so OR gate, it is a C. C is the correct option. Sixth one, the ratio of the secondary to the primary turns in a transformer are NS by NP are given us to us 3 by 2. And the output power is P. Okay, output P output is P. So neglecting all the losses, the input power must be okay. If there is no loss, then if there is no loss of power or energy, so the input power will be equal to output power then. So the power will remain same because the transformer just do one thing. It will step up or step down the voltage, okay, or current can also be changed, but the product will remain same, okay, and product gives us the power. 7. Uh, Q is equal to 2 into 10 to power minus for a dipole. Charge is given. Distance between the charges is also given. Find the maximum torque. Okay. So the torque for the dipole in electric field is given by Pe sin theta. And for the maximum value, sin theta should be 1. The maximum torque is Pe. Okay. And P is the dipole moment, which is QD. Okay. QDE. Now in the question, E is also given to us, that is 5 into 10 to power 5. Now I have to put the values. So Q is equal to into 10 to power minus 6. D is 0.01, or I can also write it 10 to power minus 2. Okay. And this is 5 into 10 to power 5. So 2 into 5 is 10 into. Now the base is same, power gets added. So minus 8 plus 5. So the answer is 10 into 10 to power minus 3. And the unit of torque is Newton meter. Okay. So the correct option will be C. Yeah. Now the eighth one. Air capacitor has a capacity. Okay. Capacitor having the capacity 10 microfarad is connected at a constant voltage battery. Voltage supply is 12 volt. Now the space between the plates is filled with liquid of dielectric. Okay. A liquid of dielectric pipe is filled in between the space of the capacitor. The additional charge flow. Okay. So now the charge we know is given by CV. Okay. So initial charge will be C naught V. Okay. And the final charge is CV. And the final, we know that when we fill the dielectric, the capacitance becomes Kc naught. Okay. So it will be Kc naught V now. Now we have to tell the additional charge. That means increase in charge. That is Q final minus Q initial. So it will be K C naught V minus C naught V. So it will be C naught V K minus 1. So C naught is in, the answer is in micron. So we just have to put the value 10 into 12. K minus K is 5. 5 minus 1 is 4. Okay. So it will be 480 and the unit is microcoulomb. Correct? Yes. Third option is correct. C is correct. Now the ninth. An ideal gas has 27 degrees Celsius is compressed adiabatically 8 by 27 of its original volume. Okay, let's say initial volume was V and now the final volume is 8 by 27 times of V. Okay, it is compressed adiabatically having adiabatic constant 5 by 3. Now we have to calculate the rise in temperature. Okay, rise in temperature, yeah, means we have to calculate delta T here. So T1, we know T initial is 27 degrees Celsius. That means 300 Kelvin. Okay, and we know V um, P V to power gamma is constant and T P to power gamma minus 1 is also constant. So from here I can write T1 V1 gamma minus 1, T2 V2 gamma minus 1, and T2 will be T1 V1 by V2 gamma minus 1. Now just put the values. So T2 will be 300, V1 is V, and V2 is 8 by 27 V. Power 3 gamma minus 1. Gamma is 5 by 3 minus 1. So it will be V to V cancel. Now 27 can be written as 3 to power 3 and 8 can also be written as 2 to power 2 or 3. Okay. And the whole power is 2 by 3. Now we can see that 3, the power 3 is getting cancelled. So the, okay, yeah, there is a 300 also. So now we can see that 3 is getting cancelled. So it will be 9 by 4 into 300. So it will be 75, 75 and 9. So it will be 675 Kelvin. Okay. So we have to calculate the rise in temperature. No? So it will be T2 minus T1. That is 675 minus 300. The answer is 375 Kelvin. So the correct option is B. Now the 10th question. 2 kg mass lying on the table displaced in the horizontal direction through 50 centimeter. Okay, mass is 2 kg and displacement is 50 centimeter. The work done by normal reaction. Okay. So the normal reaction acting in bidirection upward, force is applied in this direction and displacement is also in this direction. So we can see that the angle between normal reaction and displacement is 90 degrees. So work by normal reaction will be N T cos 90 and cos 90 is 0. So the work done by normal reaction will be 0 in this case. Clear? It's question number 10. So it is option A correct. 11. The rate of emission of radiation of a black body at 273 Kelvin is given by 273 Kelvin is E. So dq by dt is equal to E. Okay, at 273 Kelvin, 273 Kelvin, not Kelvin, it's a degree Celsius. So add 273 degrees Celsius. Okay. Then rate of emission of radiation of the body at 0 degrees Celsius. Okay. So we know that dq by dt for the same body is proportional to t to power 4. Okay. Let's say for the second time it is E2. Okay. So we can say E2 proportional to t to power 4, t to power 4, right? So I can divide the two equations and I will get E2 by E1 is equal to T2 by T1 power 4. So T2 is 0 degree Celsius and degree Celsius in Kelvin is 273. Okay. and T1 is 273 Kelvin, and 273 Kelvin in, oh sorry, 273 degree. 273 degree in Kelvin is, at 273 in 273, it will be 6, 4, 1, 5, 546. 546 power 4. So it will cancel by 2. So 1 by 2 to power 4 will be 1 by 16. So E2 is equal to E1 by 16, and E1 is equal to E. So the answer is E by 16. The first option is correct. 12th, the ratio of coefficient of thermal conductivity of two material is K1 by K2 is given to us, that is 5 by 2. If the thermal resistance of the rods are same, okay, so R1 is equal to R2, and the area is same also, we have to calculate the ratio of length. Okay, so the resistance is given by L by Ka. Okay, now we have same resistance on both sides now. So I can say L1 by K1A equal to L2 by K2A. Okay, A get cancelled. So L1 by L2 will be equal to K1 by K2. And it is 5 by, so the correct option is, sorry, 5 by not 2, 5 by 3 is given to us. No? In the question, it is 5 by 3. Yeah, sorry, 5 by 3. The correct option is B. 13th, due to capillary action, liquid will rise in tube if the angle of contact. Okay, so if this is the capillary, then liquid will rise if it makes a shape like this, and it is concave shape, concave upwards. Okay, okay. Now see, what is the angle of contact? So this is the angle of contact here, theta. So if theta is less than 90 degree, then the shape will be concave. And in case of concave shape, the liquid rises up. Okay. So theta should be less than 90. That means acute angle. So the correct option is A. Okay. If the angle is obtuse, then the liquid will drop. Okay. The level of liquid will drop from the original level. Water is flowing through the non-uniform radius tube if the ratio of the radius of entry and the exit pipe is this. So R1 by R2. Okay. Entering, let's say entering radius is R1 and exiting point radius is R2 is given to us 3 by 2. The ratio of the velocities of entry and exit. Okay, we have to calculate V1 by V2 then. So according to equation of continuity, V1 A1 equal to V2 A2. So V1 by V2 we have to calculate. So it will be A2 by A1, and area is pi r square. So it will be R2 by R1 whole square. And R2 by R1 is given to us, that is 3 by, no, oh sorry, R1 by R2 is given to us. So R2 by R1 will be 2 by 3 square, that is 4 by 9 now. The ratio is 4 by 9, that is option 1, means A. 15th question. Two artificial satellites of mass m1, m2 are moving with velocity v1, v2 in orbit of the radius r1, r2. For r1 greater than r2, then which of the following? Okay, so two satellites are revolving in a orbit. So the in the orbits, the angular momentum is constant, we know, constant. Okay, so we can say v1 r1 will be equal to v2 r2. Okay, now so here v1 by v2 will be equal to r2 by r1. Now r1 is greater than r2. That means r2 by r1 will be less than 1. That means v1 will be less than v2. So the option 3 is correct. Okay. 16th question. A body weight W Newton at the surface of the earth its weight at the height equal to half of the radius. So h is r by 2 now. So we know weight, okay, we know acceleration due to gravity at a height h is given by 1 plus h by r whole square. If I multiply by m both sides, so it will be w dash and it will be w, okay, plus what is the value of h? H is r by 2 whole square. So I get cancelled. So it will be when I solve this equation, I will get w by 3 by 2 whole square. So w dash is equal to 4 by 9 times w. Okay. So the third option is correct. See. 17. Gravitational force between two masses at a distance t apart is 6 Newton. If these masses are taken to the moon and kept at same separation, then the force between them. Okay, the gravitational force between two masses m1 and m2 is unaffected by the presence of any other mass. Okay, so if the force between the two masses on the surface of Earth is 6, then it will remain 6 at any planet. Okay, so the force will remain same. So the D option is correct. 18th, when constant torque is acting on a body, then okay, torque is equal to I alpha. Okay, and I is the moment of inertia of a body. So if torque is constant, that means alpha is also constant. Okay, and what is alpha? Alpha is angular velocity, angular acceleration. So the option, let us read the option. Body maintained its state or moves in a straight line. So there is a torque acting now, a constant torque. So body will not move in a straight line. Okay. Acquire linear acceleration. So there is no linear acceleration if the body is not moving in a straight line. Acquire angular acceleration. Acquires angular acceleration. Yeah, angular acceleration is there. Rotates with constant angular velocity. No, if the velocity is constant, then the angular acceleration would be 0. That means C, only C option is correct. Okay. 19th, a solid cylinder of mass 20 kg and has length 1 meter, radius 0.2 meter. The moment of inertia about geometrical axis. Okay, so this is the cylinder and this is the geometrical axis. So if we see the cylinder from upward, we will see the shape of disk. So the moment of inertia about the geometrical axis will be mr square by 2. This is the moment of inertia of the disk. Okay. So when we put the values, we have the values. So 1 by 2, m is 20 and r is 0.2. So I can write it as 2 by 10 now, whole square. So this will be 5. And when I cancel this, it will be 10. I will have 10 into 1 by 25. That is 2 by 5. This is 0.4. So the moment of inertia is 0.4 and the unit is kg meter per kg meter square. Okay. So units are same in all options. So correct option is B. 20. A 1 kg ball falls from a height of 25 centimeter. Okay. The mass is 1 kg. Height of initial height is 25 centimeter. And rebound up to height 9 centimeter. The final height is 9 centimeters. The coefficient of restitution. Okay. Coefficient of restitution is given by final height, final velocity divided by initial velocity. So let us consider see the case. Let's say ball is falling from this h1, hi, okay, or while striking the ground, its velocity is v1. After once it's rebound, during rebounding, its velocity is v2. So v1 is given by root under 2g h1 or hi, and v2 is given by root under 2g hf. Okay. Now V1 is Vi and V2 is Vf. Okay. So just put the value. It will be root under 2g hf divided by 2g hi. Okay. 2g cancel and it will be root under hf by hi. Hf is 9 and hi is 25. Okay. So root of 9 by 25 is 3 by 5 and that is 0.6. So the coefficient of restitution is 0.6. A option is correct. 21. A car of mass m is moving in a level road. Track of radius r and mu s is the represent the static friction. Okay, tire car maximum speed. Okay, so when a car moves in a circular path of a level road, so the safest speed is known as maximum speed of the car is mu s rg. It's a direct formula. So the second option is correct. Okay, the 22. The linear and the angular acceleration of the particle A is 10 meter per second square and angular acceleration 5 radian per second square. Actually, it will be at a distance from the axis of rotation. So we have to calculate the distance from the axis of rotation. So we know linear acceleration is given by r alpha, where r is the distance from the axis of rotation, okay, of the particle. So r is equal to a by alpha. Now we know the values. Just solve the put the values and solve it. So it will be 10 by 5. That is 2. That will be 2 meter. Okay, 2 meters. So D option is correct. 23. 23. Okay. Spring of a spring constant K equal to 8,800 Newton per meter has an extension. So x1, let's say 5 centimeter. Work done in extending it from okay x1 to x2. So we know the work done is given by when we extend the length is given by half k x2 square minus x1 square. So it will be half k is 800 x2 is 15 square 225 minus 5 square 25. So it will be 1 by 2 into 800 into 200. Now we have taken the value of x in centimeter and we are squaring the x here. So when we convert the centimeter in meter, it is 10 to power minus 2 and we are squaring it, so it is minus 4 now. So 2 to 2 cancel and there are 4 zeros already. 4, so it will be 2 to 2 cancel. So it will be 8 joule only. Okay, so the correct option is 24. Then 24th question, gas is expanding from volume V1 to volume V2 in 3 processes shown in the figure. If UA, UB, UC, UD represent the internal energies of the gas in state A, B, C, D, respectively, the which of the following is not correct? Okay, so UA, B, and C. Okay, which of the following is not correct? Okay, see. First one is isobaric. Okay, so let us check the options now. So iso let us start with the second now, isothermal. So isothermal. So for isothermal, TA and TD are equal. So T it's TC. Isothermal is second now. TC is equal. Isothermal means temperature is not changing. So delta T is 0 means delta U will be 0 also. Delta 0. Okay. That means UC minus UA will be 0. Okay. So second one is correct. Okay. And now Mm, okay, for first isobaric. So isobaric is constant pressure. Okay, so constant pressure in isobaric, delta delta U is given by NCV. Okay, delta U is given by NCV dt na del T. Okay, see isobaric. So isobaric pressure constant. So V is directly proportional to temperature. So temperature is increasing since see when we move from A to this point B. So temp volume is increasing. That means temperature will also increase, and internal energy is a function of temperature only for ideal gas. So that means TB will be greater than T, sorry, UB will be greater than UA, and UB minus UA is greater than 0. So first option is also correct. Yeah. And the third one, UD minus UA. Okay. For adiabatic, let's say. For adiabatic, delta Q is 0. So if delta Q is 0, that means delta Q is given by delta U minus, plus W. So if delta Q is 0, U will be equal to minus W. Okay. See, volume is increasing. Okay. That means work is positive, and work is positive. That means delta U will be negative. Na? And what is delta U? Change in internal energy. So in adiabatic process, change in internal energy is UD minus UA, and that is negative. That means it is less than 0. So in third option, it is showing UD minus UA less than 0. So it is also correct. Now the fourth one, it says UB, UC, and UD are equal. In fourth option, it is the only one which is incorrect, because we can see that in in isothermal the temperature is same, and isobaric the internal energy is increasing, and adiabatic internal energy is decreasing. So how can we say that in all the cases, in all the points, at all the points B, C, D, the internal energy will be same? Okay, so internal energies are not same. Okay, so this is incorrect statement. Clear? Now 25. So at 25, a block of mass 2 kgs, the coefficient of static friction is this, m 2 kg mu s 0.4. Force, applied force is 2.8 Newton. The force of friction we have to calculate. So let's first calculate maximum value of friction force. We only can calculate like this. It will be mu s n. So mu s is 0.4 and n is the normal reaction now. So in this case, normal reaction will be equal to weight of the block. So what is weight? Mg. So m is 2, g is 10. So it will be 8 Newton. So here the maximum value of friction is 8 Newton, which is greater than applied force. And friction force can't be greater than applied force. So here the applied force is less. So friction force is proportional or self-adjusting force. No? So friction force will be equal to applied force in this case. Okay. So Fs will be equal to 2.8 Newton. Okay. Friction force adjusts itself, and its maximum value can be 8 Newton if the force applied was greater than 8 Newton. So the friction value will be 8 Newton. But here the force is less than 8 Newton. Na? So friction force will be equal to applied force. Okay, so here it is A option. That is correct. It is 6. Material body A, M1, exert the force on it. If the acceleration of B is A2, the magnitude of okay. Two forces are applying force on each other. Then, according to Newton's third law, okay, F12 is equal to F21. So I can say M1 A1 is equal to M2 A2. So we have to calculate acceleration of A. Let's say A1 is the acceleration of, it is given now, for the acceleration of B, it is A2. So for A1, it is M2 divided by M1. So this is the acceleration of A, body A. And the correct option is then B. 27. Body is projected at an angle with the horizontal has range. The range of horizontal is 300 meter. The time of flight, that is 6 seconds. The horizontal component of velocity. Okay. Now the range can be given as uxt. Okay. Range can be given as uxt. So ux will be r by t, and r is 300 by 6. So it will be 550 meter. 50 meter per second. So the correct option is B. 28. Wire of mass given, radius given to us, the length is given also us, maximum percentage error of the density. Okay. So the density of is given by mass per unit volume, and volume of the wire is pi r square h or L. Okay. So percentage error is given by, maximum percentage error is given by delta m by m plus 2 delta r by r plus delta L by L. Okay. So just put the values. We don't need to change the units because the units are getting cancelled here. So delta m by m, it is 0.3 divided by 0.03 plus 2, 0.5 divided by 0.005 plus 0. Sorry, not 0. It's 6 divided by 0.0 delta m by m. Okay. Wait. So I have applied, put it the value wrong way. So delta m is 0.003 na, divided by 0.3 plus 2, delta is 0.005 divided by 0.5 plus delta L is 0.06 divided by 6. So it will be now 1 by 100 plus, when we solve the values, it will be 2 by 100 plus 1 by 100 again. And we have to calculate percentage error. That is why we have to multiply it by 100 again. The denominator is same, the denominator values will be added directly, so the answer will be 4 Newton now. Not 4 Newton, it's 4%. Okay, so the D option is correct. 29. Okay. Which of the following is dimensional constant? The refractive index is a dimensional, dimension. Dielectric constant is also dimensionless constant. Relative density is also dimensionless. Not constant, it's a variable. First, second, and third, all are dimensionless variables. But the gravitational constant is dimensional constant. That means it has a fixed value. Okay. And it has a unit. Okay. What's the unit? Newton meter square per kg. Okay. Thus, it has a dimension also. The correct option is T. 30. The theorem of perpendicular axis is not applicable for determination of the moment of inertia along the diameter for which of the following. Okay. So perpendicular axis theorem is not applicable for three-dimensional dimensional objects, basically. Okay. So here the sphere is three-dimensional object, so we can't apply the perpendicular axis theorem here. So correct option will be A. For a LCR circuit, voltage across L and R is defined by pi. Yeah, correct. So let's say let's draw a graph. So this is XL, this is XC, here it is R and I in the same direction. Okay. So this kind of graph we get in the LCR circuit. So the voltage and the here VL is in this direction, VC is also in this direction, and VR is in this direction. So you can see VL and VC are 180-degree apart. Okay. The first option is correct, is correct. Current through L and R are in the same phase. So current for all are in same phase. Okay. So B is also correct. Voltage across R and L is differ by pi by 2. So see, voltage is across R and L are differ by pi by 2. So C is also correct. Voltage across L and the current through C are differ by pi by 2. So voltage across L is in this direction and current in this direction across R, L or C. Okay. For any of the component, the current is in this direction. So again, it is at pi by 2 angle. Both are pi by 2 angle apart. So D is also correct. So the correct option will be all. So the correct option is capital D. The fourth one, 32. In this question, 5 ohm resistance in AC circuit inductance point 1 is connected with it in the series. The equation of LCR is the phase difference between the current. Okay. So resistance given to us 5 ohm and inductance given to us zero point 0.1 Henry connected with the series. Okay, series connection. EMF is given 5 sine 50t. Okay, and 5 10 50 c. Phase difference we have to calculate. So for this, we can draw the graph. This is R and I in the same direction. This is VL or XL in this direction. Okay, and the graph looks like okay. So this is the graph. Okay, the resultant is in this direction. Okay, so let us take this is the angle phi. Okay, so phase difference is in this direction. Okay, so this is basically XL and this is R. We have to calculate phase difference. So we can apply tan theta, tan phi here. So tan phi is what? Perpendicular upon base. Perpendicular is XL and base is R. XL is omega L na, or ye R. So omega is what? So in this equation, the general equation is E naught sine omega t. So when we compare with the general equation, that is E equal to E naught sine omega t. So omega comes up to be 50. So 50 into 0.1 divided by R. R is 5. So it will be 50 again. So 50 to 51. So phi will be 10 phi is equal to 1 means phi is 45 degrees. That is why 45 degrees in radians, it is pi by 4. So the correct option is C. Now 33. Potential difference V is given applied across a copper wire of length L and radius R. V is double the drift velocity. Okay, so the 33. Now see, VD is given by E, capital E, M, tau. If I multiply and divide it by length, so EL will be capital V. Capital V means voltage. So it will be E V tau by ml. Okay. Now the variable is only voltage. So VD is proportional to capital V. So if I double the voltage, uh, drift velocity will also be doubled. So the correct option is A. Now 34. Displacement of the equation is given by T. Okay. So X is equal to 4 sine omega t plus 3 sine omega t plus pi by. Now X in centimeter, T is in second. Okay. Particle obviously. Okay. The amplitude of the resultant. So the amplitude when both are the sine functions. So the in that case, the phase difference between both will be omega t plus pi by t minus omega t. So the phase difference will be pi by 3 here. Okay. So the amplitude of the resultant is given by amplitude of 4 square plus 3 square plus 2 into 4 into 3 cos pi by 3. And cos pi by 3 is what? Yeah, cos pi by 3 means cos 60, that is 1 by 2. And it will be now 16 plus 9 plus, so 1 by 2 get cancelled with 2, so it will be 12 plus 4 into 3, that is 12. So it will be root 37, and that is approximate to 6 centimeter. Okay, the answer is here, the answer is B. 35. There is a body having SHM amplitude A, there is a restoring force and X is a displacement, the total energy depends. So in SHM, if there is no, damping, so the total energy is constant. Okay, so the total energy is constant and it is given by half m a square omega square. Now we don't know about the omega now, so we know omega square is equal to k by m, and we put the value, we get k half total energy is equal to half m a square into k by m, so it will be a square k by 2. So that means total energy depends on amplitude and spring constant. That is, the correct option is now B. Okay, G restoring force constant or spring constant. Now 36. The dimension of the magnetic field intensity. So it is the direct formula, direct value, if you remember. So it is m t minus 2 a minus 1. Or you can find the dimension of magnetic field by the formula F is equal to QVB. So B is equal to F by QV, and we know the dimensions of F. Q is current into time, and we know the dimension of V. So just put the dimension and solve. We will get the option B. Okay. 37. Wire having mass, length, carries a current, suspend a midway here. Okay. By magnetic uniform magnet. Okay, let me note the values. 200 gram and 1.5 meter length, and current carry is 2 ampere. It is suspended in air, magnetic field. Okay, a wire is suspended in air. Okay, and there is a horizontal magnetic field in the region, and wire is floating in the air. That means the mg weight of the wire is being balanced by a magnetic force on the wire. Okay, so we can say Fp, magnetic force on the wire, is balancing the weight, and magnetic field on the wire is EIL. Okay, this is the force on the wire. Okay, will be equal to mg. So from here, B will be equal to mg by IL. M is 200 gram now, so it will be 0.2 kg into G is equal to 10, I is equal to 2, and L is equal to 1.5. So it will be in numerator it will be 2, so 2 to 2 cancel, and it will be 1 by 1.5, that is 0.67. Okay, so correct option is yeah, D option is correct. 38. Current to 1 ampere is passing through a straight wire of length 2 meter. The magnetic field at the point in the air at a distance of 3 meter from either end, and the wire and lying on the axis of the wire. Okay, so see, this is a wire. Okay, and it is having a length of 2 meter, and a point at which we have to calculate the magnetic field lies along the axis of wire at a distance of 3 meter from any of the, let's say this end, P. So we know the magnetic field along the axis of the wire is always zero. So it is zero here, zero. The answer, correct option is D. Yeah, 39. The coordinates of a moving particle at any time t is given by, okay. The x coordinate is alpha t cube, y coordinate is beta t cube. The speed of the particle we have to calculate. The speed, or so first of all velocity or the speed, is given by vx I cap plus vy j cap. So this is the velocity of the particle. Okay. So what is the vx? Vx is dx by dt. So it will be 3 alpha t square. And vy, so it will be dy by dt. So it will be 3 beta t square. So velocity will be equal to 3 alpha t square I cap plus 3 beta t square j cap. We can take 3 t square as common. That will be alpha I cap plus beta j cap. Now the magnitude of the velocity. Okay, the magnitude will be equal to square. So 3t root under alpha square plus beta square. So this is the magnitude. Okay. So the correct option will be, yeah, the option is correct. 40. One car moving on a straight road cover 1/3 of the distance, 20. Okay. Let's say the length of the road is d and 1/3 of the length, d by 3, is covered with the speed 20 kilometer per hour, and 2/3 of the length is covered with 60 kilometer per hour. So we have to calculate the average speed. So average speed is given by total distance upon total time. So total distance is total distance d. Total time will be t1 plus t2. Okay, car will take t1 time to cover 1/3 and t2 time to cover 2/3 distance. Okay, rest of the distance means 2/3 of distance. So t1 is, so the time is distance upon speed. So it is t d by 3 divided by speed is 20. Okay, so it will be d by 60 basically. And t2 is d 2d by 3 upon 60, that is 2d by 180, and that is d by 90. So just put the values, we get d upon t by 60 plus d by 90. So we can take d as common, so it will, and cancel the d. So we'll have 90 and take the LCM, then 90 plus 60 by 60 into 90. Okay. So V average will be 60 into 90 divided by, it will be 150. 10 to 10 cancel. 3, 3. This is 5. 5 is cancel. It will be 12. 12 is a 36. Yeah. 36 kilometer per hour will be the average speed. So the correct option is D. Now the 40. One car moving on a straight road cover. Okay, sorry. So 30, 40. No, it is 41. 41. A car moving with a velocity 10 meter per second, stop distance, application of force, F. Constant force. Okay. So U1 10 meter per second. F is constant and covers a distance. So D1 is 20 meter. If the velocity of car is 630, so in second case, if the initial velocity is 30 meter per second, car stop by, okay. Now what, at what distance the car will be stopped? After what distance? So we know F is constant. That means acceleration will also be constant, and the acceleration is given by v square minus u square by 2 D. So in both the cases, car is being stopped. So final velocity will be 0. So the formula of acceleration u square by 2t. And a1 and a2 in both the cases is same. So it will be minus u1 square by 2d1 minus u2 square by 2d2. And we have the values, just put the values and find the d2. So d2 will be t1 u2 by u1 whole square. What is the value of d1? It is 20. u2 is 30 upon 20 whole square. It is 20 into 9 by 4 by 45. So 45 meter is the correct. Okay, 9, sorry, not 45, it's, yeah, wait, yes, 4, 5, 5, 9, 45. No? Okay, there is some mistake I have done. It is 20, 21. Yeah, okay, okay. So the initial velocity in first case it was 10, and in second case it is 30. So it will be 1. Okay, it will not cancel. Yeah, 180 meter. The final answer will be 180 meter. Okay, so the D option is correct. 42. In 42 question, a ray of light suffers minimum deviation when, okay, minimum deviation, minimum. When the angle of prism is 60 degree, of refractive index mu is root 2. So the angle of incident. Okay, so mu can be given as sine I upon sine R. Okay, so in case of minimum deviation, R is equal to A by 2. So just put the value, mu is equal to sine I by sine A by 2. So that means sine I will be mu times sine A by 2. So just put the values now. So sine I, mu is root 2 and sine A by 2. A is 60 means sine 30. And sine 30 is 1 by 2. So it will be root 2 into 1 by 2. That means 1 by root 2. So the sine I is equal to 1 by 2. That means I is equal to 45 degree. Okay. So the incident angle will be 45 degree. And the correct option is C, 43. An object of 5 centimeter height. So H object is 5 centimeter placed at a distance 1 meter. So U is 1 meter. 1 meter from the concave spherical. Okay. So it will be minus 1 meter, which has the radius of curvature. So R is 20. So focal length will be again half of the radius. So it will be minus 10 because see, this is the mirror. So the all the values on the left side of the mirror measured as negative. Okay, on the right it are positive. Okay, so we have to calculate the size of image now. So hi. So we only have the one formula that can measure the hi here now. Minus v by u is equal to hi by h naught. So for that we have to calculate the v also. So from mirror formula, 1 by f is equal to 1 by v plus 1 by u. So 1 by v will be equal to 1 by f minus 1 by u. So v will be equal to, just put the values now. Okay, 1 by v is equal to, okay. So values are, the answer is in centimeter. So we have to put the values in centimeter. So f is minus 10 minus u is minus 1 meter. So it will be minus 100 centimeter. It will be minus 1 by 10 plus 1 by 100. When we take the LCM and solve it, it will be 100 minus 9, so not minus 9, minus 10 plus 1. It will be V will be equal to minus 100 by 9 centimeter. Now, magnification minus V. V is minus 100 by 9 upon U. U is minus 100 equal to HI. We have to calculate, and H naught is 5. So minus to minus cancel, 100 to 100 cancel. So it will be minus 1 by 9, HI by 5. So HI will be 5 by 9 minus. Okay, answer is in decimal now. So when we divide HI, it is minus 0.55 centimeter. Okay. Okay, the magnitude was asked, so correct option is C. 44th question. A plano-convex lens is made of a glass of refractive index mu equal to 1.5. The radius of curvature of the convex surface is R. Okay, the focal length. So let us draw the plano-convex lens. So this is, let's say, plano-convex lens. Okay, so the focal, what we have to calculate? Yeah, focal length. So focal length is by mu minus 1, 1 by R1 minus 1 by R2. So R1 is the radius of plane lens, plane side. So radius of plane side is infinity. Okay, plane surface having the radius infinity. And just put the value 1 by f is equal to 1.5 minus 1. So it will be 1 by infinity. And for R2, we are measuring the radius on this side. So it will be negative 1 by minus R. Okay, because radius of the second surface is in the negative direction. So 1 by f is will be equal to 0.5, and 1 by infinity is 0, and this will be 1 by r only. Okay, so cancel, it will be 2. So here f is equal to 2r. Okay, so the correct option is C. Clear? Last question, 45. In the given circuit, the voltmeter and the electric cell are identical. Okay, identically ideal. Ideal means the voltmeter having infinite resistance. Na? Okay. The reading of the voltmeter. Now, see, we have diagram like this. 1, 1, 20, and this is voltmeter. So it is ideal voltmeter. That means it does not allow any current to pass through it. Okay, I is 0 here. So the whole current will goes in this direction. Okay, so current will go in this direction. So the reading of voltmeter will be the reading of this 1 ohm resistance. Okay, because it is connected across this 1 volt resistance now. So let us calculate first current. So current is voltage upon resistance. So what is voltage? 2 volt. And what is resistance? Resistance, this is the circuit now. The resistance is, these both resistance are in series now. So series it will be 2. The current will be 1 ampere. Now we know the current, we can calculate the voltage across 1 ohm. That is the current into the resistance. That is 1 volt. So the voltmeter reading is 1 volt. The option A is correct. Okay. So all are done now.